Hey guys, welcome to week 3 of information design. So last week we were talking about collecting data, sourcing data, and big data. This week we are going to be talking about scrubbing data, getting it clean because usually it doesn't come in the best state. And once it's clean, then we could do some analysis on that data. So we're going to go ahead and move on from the first part of the data pipeline, which is collecting and sourcing data. And this week we are going to be talking about scrubbing and analyzing data. We're also going to be talking about visualizing for insight because you really can't analyze data without visualizing it. It's much easier to see what's going on with the data when you are visualizing it as like a line chart or a bar chart to see those peaks and valleys or those comparisons of data points, rather than looking at just a wall of columns and rows of data. So let's first talk about data scrubbing. So the internet is a wonderful place to find interesting data. But most of the time, those data sets aren't in the best shape. So this is just an example of what your data could potentially look like. So in the date column, we have 2 different types of date formats. In the country column, we have tons of missing data. I'm assuming that the United States should be filled down as well as Germany should be filled down. In the address column, we have some weird characters in place of spaces. In the city column, it looks like we have some cities that are actually spelled incorrectly. So there's a lot of issues with this data set that we need to go in and fix and clean. So we need to add the United States to these columns. We need to make the date consistent when it comes to the format. We need to remove any sort of weird characters that shouldn't be there. We need to go in and fix these spelling errors. So these are just some examples of what you might come across when you are downloading data from the internet, is it's usually going to have some issues with it because it was either put together programmatically or there could definitely be human error if someone is typing all this information in. So it's good to go through your data, just see if there's any odd things happening with that and clean it up before you actually get into the analysis part of it. Sadly, most data scientists spend the majority of their time cleaning up data and getting it into the right format above everything else. Some of the issues that they stumble across are multiple data or value formats, fields with missing data, strange HTML code replacing spaces or other characters, spelling issues, etc. Luckily, there are a number of tools to make this process a lot more tolerable. So the first and most basic tool that you could use is just a simple text editor. So with text editors, you could do simple things like find and replace. So if you wanted to find all of the weird characters that are in your data, you can open it up in something like Sublime Text Edit or Text Wrangler or any other simple text editor, and then do a find and replace for those weird characters. Another slightly more advanced tool would just be using a spreadsheet application like Google Sheets or Excel. This allows you to do a lot of different things like auto-filling sections, sorting, doing some basic calculations. So if we wanted to do like an average of the min and max columns, we can do that as well. Why don't we do a quick little demo with that? So feel free to follow along with me. Here is a link to a dataset that desperately needs some cleanup. Feel free to go to bit.ly/qc-dirt-data. So let's go ahead and do that. All right, so here I have a dirty dataset in Google Sheets. So most likely you are going to be only able to view this. So the first thing we want to do is to log in and then make a copy. You can call it whatever you want. Okay, now that we have a copy, we have full access to modify this file and change it. So the first thing that I want to do is probably fill in this content here. So all the empty cells of data, we probably want to update that. So let's do, let's click on the United States. And then there's a little box on the bottom right-hand corner of the cell when you highlight it. If you click on that and drag down, that's going to duplicate everything below. I believe if you double click on it as well, it'll automatically populate all the empty cells below it. So now we have no more empty cells, so that's great. So the next thing we want to do, let's change the date. See how you have some formats where the year is first and some formats where the year is last. So I think the easiest way to do this is to select that entire column, and then you can change the format to be a date format, which will update it to the same date format across the board. Obviously, you could override that to be the year first rather than the year last. So whichever you prefer, that's completely fine. You can also do find and replace in Google Sheets or Excel too. Actually, let's copy this weird character first. And then let's select the address area. And let's go to Edit, Find and Replace. And let's paste Command V and replace it with just a space. And replace all. Done. Good. Looks good. So there's one more thing that looks like we have some issues with, and that is the spelling of some of these cities are wrong. So we have New York and then New York with an N-U-W instead of an N-E-W. Los Angeles is spelled wrong a few times. Munich is spelled wrong. Berlin is missing an I there. So the best thing to do with this is, because it's going to be hard to go through potentially thousands and thousands of rows of data to see if there's any misspelled cities in this case, there's another tool that we could use. So OpenRefine is a really great tool when it comes to data scrubbing and data cleaning. It was originally created by the data science team at Google for this specific purpose of cleaning data. So it just takes it to another level. It just is more advanced than the spreadsheet applications. One thing that I really like to do with this is there's a more advanced kind of find and replace. It's called nearest neighbor, which can find anything that's similar. So if Los Angeles is spelled wrong like 3 times, it'll find all 3 of the places that look like it should be Los Angeles. So let's go ahead and check out OpenRefine real quick. This is a free application, and you can scroll through the site and learn more about it, and then you can go to download. And you can download for Windows, Mac, and Linux. Once you've downloaded and installed it, then you can start using it. So when you open OpenRefine, it's going to open in the browser window. So it's very similar to Tabula, which is the platform that we talked about last week. So it runs in the browser. So up here, it's just running locally on your machine in the browser. So the first thing I want to do is get a data set. So let's go to our dirty data and let's download let's do a comma separated value, CSV. Let's go back to OpenRefine and let's find that file and open it into OpenRefine. Hit next, and then it just processes it. And yeah, looks good. So you create a project, and then we could start playing around with OpenRefine. So like I said, one of the things that I really like to use it for is a more advanced find and replace. So we're going to use that for the city column to find all the misspelled cities in here and fix them. So if you click on the arrow for city, go to edit cells, and then cluster and edit. This gives you some options here. So the method, we're going to use nearest neighbor. And then it automatically pops up all the cells that look similar. So we have Los Angeles is spelled 3 times, 3 different ways. Actually 4 different ways. And then New York is spelled 2 different ways. So we want to do Los Angeles, and we want to merge it with Los Angeles. That's right. That's right. And New York, that looks right too. So we do merge selected and recluster. Okay, so that looks good. So we got Los Angeles, it's all spelled correctly, and New York is all spelled correctly. So what if we want to do something a little bit more complicated? For instance, if you want to analyze and visualize the data the Apple Health Kit app collects, they will only allow you to export an XML file, which isn't always the best format for it to be in. Sometimes you want it to be in like a spreadsheet format. So for this, you would have to go straight to code. As far as I know, there's no way to automatically, easily convert XML data to like a spreadsheet format. So you can use Python or JavaScript or whatever language you're comfortable with. And this is an example in JavaScript that basically is getting the XML data, the export.xml data, and then it's looping through all that data and finding all the records, and then going through all those records and pulling out those data points for like start date and the value and the unit and type. And then it's just putting it into a comma separated value format and then displaying it in the browser, which you can then copy and paste into a spreadsheet format. So if you want to do anything more advanced, most likely that's going to require you going to code and using something like Python or JavaScript to parse through all the data and get it into a different format you want, or clean it up in some other way. But for the most part, the majority of you will only be using a spreadsheet application to do cleaning and analysis. So I wouldn't worry about getting into Python or JavaScript when it comes to scrubbing your data. So here are some examples of projects that I worked on that required different aspects of scrubbing and reformatting the data. So this is a project I did on Joe Aparo, who was a controversial former sheriff of Maricopa County in Arizona, whose policing policies and practices many people thought to be racist. So I was curious to see what his record as a sheriff was. So I was able to find all the data as individual PDFs through the Crime in Arizona reports, and those come out yearly, again in PDF format. So this required a lot of data cleanup and migration and formatting to get it all in the right format for me to actually use to analyze and visualize. So first I had to get the data out of the PDF using Tabula. Then I had to combine all these years together to actually have something I could work with to do more analysis and to eventually visualize that data. This visualization I did is based on all the global natural disasters over the years to see if there's been any sort of increase due to climate change. I found the data in this format at the top, which is separated by many different parameters. So we got location up here, and then different types of disasters at the bottom. So I really only cared about the disasters and the time because I wanted to look at it globally. So I had to put it into a nicer, cleaner format, do some general modifications to it, and this is the format that I ended up getting, which is much nicer and cleaner for actually visualizing it in the end. So let's talk about data analysis now. So once you have the data and it's clean and it's scrubbed, then you can actually start doing some analysis and getting some insight from what the data is trying to tell you. So one of the first people to analyze a data set and look at statistics to try and gain real insight was Al-Kindi in 850. He spent significant time looking at all the letters used in the Quran and noticed that certain letters were more frequently used than others. This method can be used to solve simple Caesar ciphers, which is a way to create written codes. Basically, all you do is shift every letter over a certain number of steps and use that to write your message. Looking at the frequency of letters used, you can compare it to known text frequencies and break that code. So why don't we quickly take a look at what a Caesar cipher is. So this is a website that creates a Caesar cipher for us. So basically we have some text on the left-hand side, and then here is how we can encode our Caesar cipher. So basically all we're doing is shifting our alphabet a certain number of steps. So instead of A starting, we're going to shift it 7 steps. So H is going to be the first letter of the alphabet. So basically whenever we are using an A, an H is going to replace it. Whenever we're using a B, an I is going to replace it, etc., etc. So on the right-hand side, this is our cipher text, our encoded text. Essentially, we can decode this by doing some basic analysis to see how frequently a E is being used. And based off of that, we know that E's are probably one of the highest used letters in the alphabet. So if we can determine what an E is, then we could pretty much break this code. So in this case, an E is going to be L. So we can determine that it's been shifted over 7 places in the alphabet. So in this case, we can look at codes and crack them by analyzing the data and analyzing the frequency of these letters being used in this code. So this is John Tukey, and he was one of the first data scientists to use a computer to analyze data in 1977. So he developed a programming language called Prim9 that allows the analyst to visualize the data in 9 different dimensions. So this is a clip from a video where John Tukey is talking about how Prim9 works and how visualizing it in multiple dimensions allows you to gain more insight into what the data is saying. I will add a link to this YouTube video below in the description on YouTube, as well as on the class website. So make sure to check that out. John Tukey's brother-in-law actually created this little example to show the importance of Tukey's work and how very important it is to always visualize a data set for insight. There are 4 different data sets here. If you look closely, do you guys notice anything like interesting popping out? So there's some weird things that I see anyway. So in the 4th data set, the X value is all 8s except for 19. That's really the only thing that stands out when you just look at the rows and columns of data, for me anyway. So if you actually look at the mean and the variance of X and Y for all 4 data sets, you notice they are actually all the same value. The same goes for the correlation and linear regression. So the math is telling us that they are all very similar, if not exactly the same data sets. But if we actually plot these on a graph, we see that they are all extremely different. The first just kind of looks like a random placement. The second has an obvious arc to it. The third is pretty gradual increase, except for this one outlier. The fourth is all clustered together, except for this one plotted in the upper right-hand corner. This just proves that it is always necessary to visualize any data set when we are trying to see interesting points. You can't just stare at the numbers in the spreadsheet form or rely completely on the math. So when it comes to data analysis, the main application that we're going to be using in this class is Spreadsheet Applications, so Google Sheets or Excel. You can really do a lot when it comes to analysis in these applications. So let's just play around with that a little bit. So let's go back to our Google Sheets. So why don't we go ahead and add an average column over here. So on column G, I'm going to say average. And for this, we can do write some basic formulas in Google Sheets. So to define a formula, you just put an equal sign. And then Google is nice enough to give us a suggestion of what it thinks that we want to do. And yes, we want to do an average, so let's click on that. And then it's averaging using this average function and passing in the average of E2 and F2, which is the min and max value. And it's exactly what we want. So if we hit return, it will give us the average of these 2 values. And then another great thing is that you can duplicate formulas down in a column. So if we select it and then click on that little box on the bottom right hand side, click and hold, and then drag it all the way down, it's going to apply that formula to each row individually. So just like that, we have another column for average. So we could also add filters to the spreadsheet. So if you select the top row, and we could create a filter, and this will basically allow us to sort by city. So So this is sorting by city. You can sort by country. You can sort by value. You can also add other filters if you wanted to. You can sort by color, apparently, in Google Sheets. That's pretty cool. So that is filtering and playing around with formulas in Google Sheets. If you're using Excel, it's really not that much different. It's very similar. Okay, so we could do some more advanced stuff here too. So in Google Sheets and in Excel, there's something called pivot tables. And basically what that does is it allows you to pivot the data into different views. So if we wanted to see all the values by both city and date, we could do that. If we wanted to see all the values by country and date, we could do that. So there's a lot of different things that we could do to kind of pivot this data into different formats and different views. So why don't I just quickly do that as well. So I am going to select everything. And then I am going to go to data and pivot table. And you can create a new sheet or an existing sheet. Or use the existing sheet. I'm gonna create a new sheet. And then we could see, okay, what's the average? So in Google Sheets, it gives you suggestions on what you might want to look at. So what's the average minimum value for each city? What's the count of addresses for each county, country, etc. So let's do the count of addresses for each country. So this is going to give us the rows. This is going to give us the rows for the country, and then a column for the count of the total number of addresses in that country. Then on the right-hand side, it gives us the rows and the values. So if we want to do this by, instead of country, if we want to do this by, so let's delete this and do an add rows for city. Oh, looks like there's still some spelling errors in here that I missed. So I got to fix that later. Anyway, you can do rows by city as well. You can do it by average if we wanted to. Doesn't really make a lot of sense doing that. Let's look at a new row for cities, and let's see the value for the average. And you can do the sum of the average, or you can do a count, or you can do, let's do an average of the average for each city. So this is the average value of all the different rows that apply to these cities. So you can play around with that and pivot your data into different formats depending on what you want to look at when it comes to getting insight into what your data has to offer. So like I said earlier and multiple times, it's always very important to visualize your data for insight. So you could much more easily see what's going on with the data when you visualize it in a certain way. So you can gain a lot of insight from the visualization of that data set. So you could do this really easily and quickly in Google Sheets or Excel. So let's do it in Google Sheets. So let's say we wanted to visualize this data set. So if you highlight it, you can go to Insert, and then Chart. And then it's automatically just going to pop up a chart for you. So it gives you a bar chart, but you could change that if you wanted to. So we can do average column charts. We can do a line chart if we wanted to. We can do a plot, scatter plot. For something like this that's comparative, then a bar or a column chart is probably best. So this really shows you it's a lot easier to see what's going on with the data and like which is the highest and which is the lowest, rather than just staring at this spreadsheet. It's a little bit more complicated and harder for us to determine what's going on. But here we could instantly see that this bar is the largest and this bar is the smallest. So just as an exercise, when it comes to the data for City Bike in New York City is actually publicly available. So you can get that data and play around with it and just do some analysis on it. So I actually got it for you guys. So if you go to this bit.ly link at the top, I'll add this link to the description in YouTube as well as on the class website. But if you go to that link, then you can get the data to play around with it. So this data contains a date, trips over the past 24 hours, trips since the launch of the platform, miles traveled today, miles traveled to date, total annual members, total member signups for the day, I believe, total 24-hour passes for that particular day, and 7-day passes purchased for that particular day. So some things that you could look at and play around with is do some analysis on the time of year and the distance traveled, or the time of year and the total number of 7-day passes purchased, or maybe looking at it by the days of the week and the total number of 7-day passes purchased. So if you do that, then you can maybe gain some insight into what days are the most popular for city bike riders to rent a bike or purchase a pass. What time of year is city bike most regularly used? So those are the things that you can kind of look into and do some analysis on. And you would probably want to do that with pivot tables. So I'd play around with pivot tables using this data to gain some insight from it. So like I said, all this city bike data is publicly available. So if you go to this link at the top, you could actually see all the data, more recent data most likely, more recent data than what I just provided you. And we're going to talk about APIs later, but there's also an API if you're really interested in doing something with this city bike data in real time. So with live data, you could totally do that as well. So another thing that you can play around with when it comes to playing around with city bike data is looking at how it correlates to something else. So one thing that you can look at is there a correlation between weather and the amount of people that are using city bike on a certain day or during a certain time period. You can get historical weather data from a number of different sources online. So I think AccuWeather.com allows you to download historical weather data too. So that is another thing to look at, is finding correlation between multiple data sets. So is there a correlation between city bike data and weather data for any given day, week, or year? That's something else to look at and see if there's any sort of overlap or correlation with those two data sets. So when it comes to analysis, there are a number of different platforms and applications that you could use. Data scientists use R as one of their main tools. I'm not a huge fan of R. I find it very complicated, but some people love it. So if you are one of those people, then that's great. There is also RStudio, which is a much more user-friendly way of working with R, but again, I find it a little complicated. Then there is also Python. So Python is used by a lot of people who work with data for analysis and cleaning and collection. And there's a library called Pandas that is really great for data analysis. If you're interested in programming, then Python is probably a good language to use and learn if you want to play around with data. So today, pretty much every company is using their users' data to help them predict the future and understand trends. And essentially, data is a new currency. So all of these organizations are collecting data on their users and using that to sell them items, or using it to display advertising, or selling it to other organizations or companies to sell you advertising and sell you different things. So here's an example that Google actually did when it came to data analysis, which was really interesting. They looked at different correlations when it came to the flu or colds and the Google search data. So if people were searching for Kleenex or cold flu medicine in certain areas, they can determine that there's probably going to be a spike in the cold or the flu or the influenza in that particular area. So this obviously would probably be helpful today if we could find correlation with COVID-19 and what people are searching online, or how they're interacting with Google in certain ways. So that's an interesting way to find correlations between two different data sets. So one is looking at the Google search data, and the second is looking at the influenza flu data and seeing if there's any sort of correlation between those two data sets. And based off of that correlation, based off of that analysis, you can determine where there's hotspots currently, and you could also potentially predict where there could be hotspots for the flu or influenza, or even today, potentially COVID-19. So another great example is looking at baseball and baseball statistics, and especially when it comes to putting together teams. So the Oakland A's hired this guy, Billy Beane, as their GM in 2002, and he used statistics and data analysis to build a team, looking at all the traditional baseball statistics like on-base percentage, RBIs, hits, steals, etc. And he was able to use that data to put together a team that was actually very inexpensive. So he knew what he was looking for, and he knew the different components that he needed. And he didn't need like the $40 million big hitter. He just needed like good pitchers, good midfield, good outfield, etc. So he took all this data and looked at it and determined what he needed to make a good baseball team with the least amount of money. So they, in 2002, were spending the third least amount of money on their players. And that season, they had a 20-game winning streak and were first in their division. So they had one of their best seasons and spent the least amount of money, or very little money, to get the team that they needed to get that winning season. So this actually turned into a book, Moneyball, which obviously turned into a movie with Brad Pitt and Jonah Hill, which was very successful and good movie, good book. You should definitely check it out. Another company that is known for their data analysis is Netflix. They have collected data on more than 25 million users. And this is actually old statistics, so it's probably much more than that. They track 3 million plays per day, 2 billion hours were streamed in 2011, 4 million users ratings per day, 3 million searches per day. They know where people are watching, the device they are using, time of day, metadata from third parties, social data, and they use all of this data to figure out what they need to produce when it comes to the shows and movies that they provide for their audience. So one example where they use this information to correctly predict a successful series was for the remake of House of Cards. Based on the data, they knew that most of their users that enjoyed the original BBC series also loved, at the time, Kevin Spacey movies and movies directed by David Fincher. Because of this, they decided to finance a remake of the series starring Spacey and directed by Fincher. Before the launch, they did target advertising to make sure the people who would watch the show did. So obviously times have changed since then, and this probably wouldn't be as successful as it was then because of everything that happened with Spacey. But at the time, it was very successful. And it was a big win for Netflix. So now they are applying this method to all of their TV shows and movies. So Stranger Things is entirely successful because of this data that they use to analyze what's successful for their users and what would be of interest to them. Orange and the New Black is also very successful. Cheer is a very successful documentary. Lock and Key, etc., etc. So there's tons of really successful content that Netflix has produced, and all of that is based off of data analysis on the data that they have collected on what their users have been watching already. So if you're interested in learning more about like who's tracking you when you go to certain websites, there's a really great plugin called Ghostery. It's a Chrome extension, and basically it just shows you all of the third-party platforms that are tracking everything you do on any website. So some things might be like Google Analytics would pop up. Then there are like Google AdWords and advertising trackers, etc., etc. So this is a pretty cool platform to add to your Chrome browser to see who's tracking you and what they're looking at. And then you could also block some of these trackers if you wanted to. So another thing to check out and kind of look into when it comes to data analysis is machine learning or artificial intelligence. So there's a really great video that I'll link to on the description and the class website that goes into kind of what is machine learning and what is artificial intelligence and how is it affecting our daily life. But essentially it's just machines and algorithms looking at large amounts of data in real time and giving some sort of response based off that information. And the more data that it intakes, the more it learns and the better it gets at giving you recommendations based off of that data. So if you're interested in learning more about artificial intelligence, there's a really great site that shows some of these Google experiments with AI that are worth checking out. So again, I'll link to this site in the description as well as on the class website. But why don't we check out one real quick now? So here is some information around what AI experiments at Google is. And then you could also go to the experiments directly. So let's see if I could find one that's of interest. So here's one that's pretty fun. So let's launch this experiment. So this is called Quick Draw. So basically you are asked to draw a different object in under 20 seconds and the artificial intelligence will try and guess what you're drawing. So I have to draw a kangaroo. All right, so there is a head.
I see circle. I see ring or apple or blueberry or frog or sea turtle. I see bear or owl or cat or bat. Oh, I know, it's kangaroo.
Cool. So it got a kangaroo. Let's try a speedboat.
I see line. I see canoe. Oh, I know, it's speedboat.
Wow, that's pretty good. Cool. So if you are interested in learning more about machine learning and AI, then there is another platform called ML5JS, which is a JavaScript framework for doing some really fun stuff with machine learning. So you could do some similar stuff to what is listed in the Google AI experiments. So I would check this out if you're interested in programming at all. So here's a little assignment that I want you guys to work on. So find a data set online, clean it up, and put it in a format you can work with. You can use the data set you found during last class if you wanted to. So once the data is clean, then use either Google Sheets or Excel to start playing around with the values, using pivot tables and other tools and techniques to pull out interesting points. Remember to always quickly visualize your data for insight, because it's really hard to see what's going on with the data just looking at rows and columns of numbers. So you always want to visualize it constantly. So that's it for this video. Look at the class website again for the homework assignment or any other information. And feel free to email me with any questions or Slack me. I'm happy to answer them. All right. Thanks, guys. Bye.